The basic interventionist notion of causation, I think, is a very kind of weak or minimal notion. All that it really involves is the idea that there's some way of wiggling the candidate cause such that the candidate effect will change. Well, obviously, in many contexts, you want to know a lot more than that. I just want to say, if you're a philosopher or even someone in another discipline, this whole complex of questions and issues is a really it's kind of fruitful and interesting place to be from my point of view. In my own case, the reason why I went into philosophy to begin with was I thought that it kind of gave me a license to stick my nose into all sorts of different things. And that's what I've done in my career. And I found it on balance very, very satisfying.
This is Brain Inspired.
The nature of causality and causal explanation has occupied philosophers since there were philosophers. What does it mean when some thing or event or process causes some effect? Hello, everyone. I'm Paul, and my guest today is James Woodward, who's a recently retired professor from the Department of History and Philosophy of Science at the University of Pittsburgh. Jim has written extensively not about what causation is per se, but about what causation does. He begins with a minimal notion of causality, often called interventionism, which is simply the idea that if you were to intervene on a cause, or wiggle the cause, as Jim sometimes says, then it would make a difference to the effect. From that simple notion, things quickly get more complicated, with questions about how reliable a cause is, how many different ways we can explore a cause, how to treat causes and effects at different levels of granularity, how much of some single cause we can attribute to an effect with multiple causes, and so on. Much of that work was done in Jim's 2003 book, Making Things Happen, A Theory of Causal Explanation. And in his most recent book, Causation with a Human Face, he uses the interventionist framework of causality to expand on those ideas, and in particular to explore the relationship between how we should think about causality, making claims about causality under the interventionist framework, and how we humans actually do think about causality, how we make judgments about and reason about causality in the world, our causal cognition. For Jim, these usually separate lines of research have a lot to teach each other. So we discussed those ideas, some of the other major and minor themes in the new book, and of course much more. In the show notes, I link to both books that I mentioned. Find them at braininspired.co/podcast/145. To my Patreon supporters and students in my Neuro AI course, I salute you for your support and generosity. I recognize it's not the default to take action to support a podcast, and I feel a deep gratitude to you. Thank you. Here's Jim. Jim, welcome back, old friend.
Well, thank you, sir.
I say old friend, of course, because this is actually take 2 of our attempt at recording a podcast episode due to yours truly's, what's a euphemism, ongoing challenges as a podcast creator, perhaps. So I really appreciate you doing this again. And we won't repeat verbatim what we did last time, but we'll see.
Okay, sounds great.
So your new book, Causation with a Human Face, follows almost a decade after your, what I would call now classic book, Making Things Happen. And in some sense, the new book, Causation with a Human Face, is a continuation or an expansion of what you did in Making Things Happen. So in Making Things Happen, you introduced your interventionist framework for approaching causation. And you revisit that in Causation with a Human Face. But then you go on to do things that you alluded to, at least, and did a little bit in Making Things Happen, where you take this functionalist perspective on causation. And in that regard, you focus on connecting an account of causation itself, what causation, quote unquote, is, with how we do causation, something called causal cognition, how we make judgments about causation and reason about causation in the world. Could you elaborate? Maybe, we're going to have to talk about what we're going to have to talk about what the interventionist approach is, but maybe before that, can you, elaborate on this functionalist approach and why you chose it, why you think it's an important way to proceed?
Be happy to do that. So to begin with, the functionalist approach, it's just the idea that we think causally, we engage in causal reasoning because it's useful for us. In other words, causal thinking is functional. And I claim that imposes various kinds of constraints on how we as philosophers or inquirers in general should think about causation. So that's the basic picture of the functional aspect of causation. You alluded to the idea that my view is an interventionist view, and that's right. It's a view that connects causal claims with claims about what would happen if you were to get in there and manipulate things. So if C causes E, then if you manipulate C in the right way or you intervene on C in the right way, then E will change. And that's at least an important part of my story about the functionality of causation. Causal knowledge is functional for us because it encodes information that we can use to manipulate and control.
So I know that there are other people that have this kind of functionalist approach, like Udaya Pearl and so on, who've been working on this, but the history of the philosophy of causation hasn't really followed that so much, right? It's been much more concerned with sort of the metaphysical, what causation is part of the question, going back to Hume and of course, Aristotle and all those good old philosophers. But you allude to this a little bit in Making Things Happen as well, but you spend more time on it in your recent book on the difference between epistemology and metaphysics and why you think that there shouldn't be necessarily such a difference. And in my view, you almost, it could be interpreted as if you say, well, as if it's you saying, well, I don't really want to talk about metaphysics because it's not important. But at the same time, you're kind of saying they should be talked about in the same vein. So why do you hate metaphysics? What's that about?
I don't know that I would say that I hate metaphysics, but what I do think is this, and I try to say this clearly in the book, that the pursuit of an inquiry into the so-called metaphysics of causation that completely neglects the epistemology or the methodology of how we find out about causal relationships is not going to be very fruitful. And I think there is at least some tendency in people who work on the analytical metaphysics of causation to completely neglect the epistemological side of things. So in other words, the idea is that metaphysics is one thing, epistemology is something completely different. It's a consequence of my functional way of thinking about causation that those two things, epistemology and metaphysics, should not be taken as completely separate. Because according to me, we're interested in causal relations because this is useful information for us. And that means that we have to be thinking about causation in such a way that there are ways of finding out whether causal relationships in the world obtain or not. And so from the functionalist point of view, it's a kind of constraint on any adequate theory of causation that it should link up with the procedures that we actually have for finding out which causal relationships obtain in the world.
So metaphysics, not useless, but perhaps less useful for the way we actually do causation in the world.
What I do think is, so from my point of view, there are kind of two projects associated with causation or causal reasoning that I find interesting. One, as I say in the book, is a normative project. How should we think or reason causally. And you find this normative aspect of things certainly addressed in the philosophical literature, but also in literature on machine learning, where there's a lot of interest in, how you can learn about causal relationships from, for example, observational data. There's a flourishing tradition in statistics and econometrics that is also normative. So what I hope is that the book makes some contribution to those kinds of normative concerns. I think that's a completely valuable and interesting project. And then the other issue, which I find intellectually very interesting, is how, in fact, do we do it? As a descriptive matter, how is it that people think causally? And how is it that when they think causally, at least to some substantial amount of time, they're successful in identifying causal relationships? So I guess it would be a fair thing to say about the book that it focuses on those two projects, what I call the normative and descriptive, and shall we say, is at least kind of quietist about what the underlying metaphysical story is. And that quietism is completely intentional. It's not that it doesn't occur to me that some people out there think that one should provide a metaphysical story. I deliberately refrain from trying to provide one, at least of any very elaborate sort.
Well, I mean, being quiet can be pretty loud. So have you received pushback from the metaphysicians out there that you're not paying enough attention or doing enough service toward metaphysics? We're not going to harp on metaphysics for long, I promise. But
okay, well, good. But yeah, certainly. And even in connection with the first book, it was a kind of ongoing complaint that I really hadn't provided an underlying metaphysics of causation. So, for example, I talk about what would happen to one variable if you intervene and change the value of another. But people have said to me, well, okay, but what are the truth makers for those claims about what would happen if you were to intervene? What's the underlying story about what's going on at a metaphysical level? Are you committed to powers or dispositions as your account of causation, or maybe relations of necessitation between universals, or maybe something else? And I have to say that I just don't find the focus on those kinds of issues, and there's certainly a lot of it in the metaphysics of causation literature. I just don't think it's been fruitful in comparison with these other kinds of issues, both the normative ones and the descriptive ones, about how, in fact, we do it, where it seems to me there's been a lot of really recognizable progress made. We've learned a lot of new things there. And I don't think that there's been, frankly, anything that is comparable in the analytical metaphysics of causation.
Well, you used the word fruitful there, which I believe you use in the book as well, and that is part of the functionalist approach. And I think that, maybe that's one reason why, at least from my perspective, in the neuroscience world, and I guess in the biological world, a lot of people have really embraced this interventionist brand of causation because it lends itself well to actual experimentation. I know it doesn't require an experiment because you can infer causation from observable data as well. But so maybe just in terms of another background to your approach, you mentioned that earlier that people often are causally correct or fruitful in their causal judgments. And this has to do with the rational approach that you also take in thinking that there's a normative aspect there where people are rationally approaching judgments of causation. I don't know if you have more to say about that. I'm not sure I have a question. I just wanted to make sure we got that out there, because I guess on the other side of the coin, there are a lot of people who focus on our foibles. I'm part of that group. I think I go both ways, but you're more focused on the rational, fruitful, correct judgments of causation, right?
That's true. So just to say a little bit more about that, I said a moment ago that I was interested both in normative issues about how we ought to reason causally and descriptive issues about how we in fact do. But I see these as closely interconnected in just the way that you described. That is, I think it's true, and I realize this is controversial, but I think it's true as a matter of empirical fact that at least a substantial amount of the time, people do reason in normatively appropriate ways. And so looking at normative models of causal cognition often is useful in answering descriptive questions about how people in fact reason causally. This perspective is certainly not unique or original with me. I think it's very widely adopted in the causal cognition literature, where at least a whole lot of the people working in this area, psychologists and cognitive scientists, do tend to assume some sort of rational model picture of causal cognition. Now, I realize that this stands in contrast to another tradition in psychology, which focuses much more on the mistakes we make, our biases, et cetera, et cetera. I guess I just find it more interesting somehow and more worthwhile. And maybe at some level kind of more respectful to human subjects that are in these experiments, if we try to understand to what extent what they're doing may turn out to be rational or normatively appropriate. And I mentioned in the book several cases in which people engage in certain patterns of causal reasoning. The initial reaction was, oh, this shows that people are being irrational or acting in normatively inappropriate ways. And then we've come to realize that actually, no, it was the normative analysis that was wrong. If we kind of think in a kind of deeper and more sophisticated way about what's normatively appropriate, it turns out, at least in some range of cases, that their cognition is rational after all.
Can I put you on the spot and have you describe one of those examples, maybe your favorite example of that?
Okay, so there's a measure of what's called causal strength. That is, so a lot of the psychological literature makes use of subjects' judgments of what's called causal strength, where this corresponds to the subject's response to something like the question, how good of a cause would you say that C is for E? So this is the experimental data that at least some psychologists try to fit. A simple measure of that you might think is the normatively correct one when you have two binary events, a cause C that can take one of two values on or off, and an effect E that can take one or two values on or off. You might think that the normatively appropriate judgment of causal strength to make in that case is just to take the conditional probability of the effect in the presence of the cause and subtract from that what the conditional probability of the effect would be in the absence of the cause. This is called delta P, and people noticed when they did these, they looked at this issue experimentally, that subjects weren't always judging in accordance with delta P. And it turns out that there's a very good normative reason why they don't do that. And I won't go into a lot of details, but it's laid out very clearly in, for example, work that Patricia Chang at UCLA has done. And the basic problem is that if you're just focusing on delta P, you're not adequately or appropriately controlling for the possibility that there may be other causes of E present besides C. So Chang has a somewhat more complicated measure, which tracks, at least in some respects, causal strength judgments that subjects make much better than the naive delta P does. So that's just one example. I can give you a number of others if you're interested.
Yeah, well, you use a lot of examples in the book. I mean, obviously, we're not going to go through all of them, but I just thought it'd be useful as we go along to maybe visit some of the examples
Sure.
about the various topics in the book. So let's see, where do we go from here? Maybe let's back up for a moment because, well, you know what? Let's not back up. This is a terribly unfair question, but just in a broad sense, and you've been talking about this a little bit already. What is the relationship between the normative and the normative and the descriptive? How do we broadly judge causal reasoning? I mean, is your rational perspective, has it borne out to a successful, such that you think it's a successful and how do I put this? Has championed your rational approach? Have the results from cognitive sciences championed the rational approach? Like, how do you what's the big conclusion? Because you go through a lot of examples in the book. What's the big conclusion about how we judge and reason causality?
So I think the question you're asked, or one question you're asking, is how do we tell whether a normative proposal about causal reasoning is correct or appropriate? Is that's
yes, yeah.
Question? So my answer to that is a kind of means end type answer. That is, we specify some goal, what it is that we want to learn or figure out about, and typically in this sort of context, this will be learning about some particular kind of causal concept. One of the themes of the book is that there are a whole variety of different
I want to come to that
causal concepts. So one of the things you need to do is to just specify clearly right at the beginning what concept it is that you are interested in. I think of all of the causal concepts as connected in one way or another to issues about what would happen under interventions, but the connections are different in different cases. So suppose I say that, what I want to learn is whether if I were to perform an intervention on C, E would change. So that's my goal. Then there are a variety of different ways in which I might try to answer that question, depending upon the kind of data that I have available to me. If I can actually do an experiment in which I manipulate C and see what happens to E, okay, that's really straightforward. There's no complexity there. But suppose I can't do an experiment. Suppose I just have so-called observational data, where that means that the data is observed, but it hasn't come from any kind of deliberate experiment. Then the question I should be asking myself is, can I somehow get information out of the observational data, perhaps in conjunction with other assumptions that I think are well supported, that would allow me to answer this question about what would happen if I were to perform an intervention in which I change C, and how can I get an answer to the question of whether E would change under that kind of intervention. And under some circumstances, you can actually produce mathematical proofs that if certain assumptions are satisfied and you have certain information, then you are going to be able to answer that question about what will happen under an experiment. That's if the experimental manipulation were to be performed. So that's one way of getting at the normative question. Sometimes you can at least get at the normative question, or at least suggest that you're doing, that there's something right about your normative proposal, just by investigating various kinds of inference strategies empirically. So I don't talk about this in the book, but I do talk about it in a long subsequent paper that I published earlier this year in a journal called Theoria. There's been a lot of interesting work in the machine learning literature concerning causal inference on the problem of inferring causal direction. So suppose you have two correlated variables, X and Y. You know that there's no common cause. so there isn't confounding in that sense. But you don't have any kind of temporal information that will allow you to determine which is the cause and which is the effect. In the past, people have thought if you're just, and you can't do an experiment, you're just observationally seeing a correlation of some kind between X and Y. In the past, people have thought this was an insoluble problem. You can't figure out whether X is causing Y or Y is causing X. It turns out that given certain assumptions, there are techniques for solving this problem that work pretty well. And there are mathematical reasons why they work pretty well. But in addition, the people who devised these techniques, they went out and they looked at cases where the causal direction was independently known. And they applied their techniques to these cases. And it turned out that the procedures, just as an empirical matter, work fairly well. So one of the things that they did, for example, was to look at the correlations between altitude and rainfall in Germany. Well, of course, you think that it's the altitude that's causing the rainfall rather than vice versa. And sure enough, the results are pretty good at reproducing that result. So they're sort of empirical calibrationist arguments that you can make as well. So my general story about rationality, it's a kind of means end or hypothetical imperative picture. Are the means you're employing, like a certain inference strategy or something like that, getting you to the end that you want to achieve? Now, I think it's true, as I've been saying earlier, that at least a fair amount of the time, it turns out that people, the methods that ordinary folk use, in fact, do have a kind of rational or normative justification of the sort that I just described. But I'm not claiming that those methods that people use are justified just because people use them. There has to be some kind of independent justification of the means end sort that I was just describing a moment ago. So this is not, there's some philosophers who may think that we just take people's ordinary judgments about things and we kind of systematize them and we describe them, and that's the correct story about how we should think about causation, or the normatively appropriate story about causal reasoning. I wouldn't claim anything like that at all. I think you need some sort of independent justification of this means end sort that I was describing. But I think, in fact, given that standard, it does turn out that people often reason causally in normatively appropriate ways.
So one of the lessons that I drew from the book, which was kind of a downer, really, is just how complicated causation is. And It just, every freaking subject just turns out to be super complicated the more you dig into it. And that there are so there's a couple different ways we could go here. Being an ex-neuroscientist, I'm automatically, reflexively wanting to talk about scaling up notions of complexity. But before we do that, maybe as even kind of a teaser, maybe we should talk about different notions of complexity, because, growing up, I guess in my naivete, growing up scientifically, it seems like, okay, there's one kind of cause. There's one notion, a thing can cause something or not. And I wasn't hip to the notions of proportionality, of invariance, of different notions of causality. So maybe we can go through and just tease out why why there's not just a single way to think about causation and some of the different notions of causality.
Okay. Well, as you say, this is a somewhat complicated landscape, at least from my point of view. Philosophers themselves have distinguished at least several different causal notions. So one familiar contrast is the contrast between so-called type causation and token causation. Type causation has to do with something like a repeatable causal relation. So if I say that smoking causes lung cancer, that's a so-called type causal relation. A token causal relation, or sometimes nowadays it's called an actual cause relation, is a claim to the effect that, for example, some particular person, Joe Jones, his lung cancer was caused by smoking. So that's one contrast. And the way in which you find out about type level claims and the way in which you find out about token level claims is an important way. It's pretty different. So any treatment of causation has to be sensitive to that contrast to begin with. There are other kinds of contrasts too that I could go into, and I'm not sure how useful they'll be to the reader. But someone who I would particularly recommend in this connection is Judah Pearl, particularly in recent work. And he's been very, very sensitive to different kinds of causal notions that really correspond to very different kinds of causal questions we might want to ask about a system. I mean, for example, we might want to ask, does this cause in aggregate have a sort of total or net effect on some effect of interest? That's one thing we might be interested in. But often, particularly in biological, but also in other sorts of contexts, we have the idea that a cause can influence an effect by many, many different routes along lots of different routes. So if in a neurobiological context, if you give a subject a stimulus, there may be a number of different neuronal routes that lead to some overall response in the brain. You might be interested not just in the overall effect, but what happens along those individual routes. And that's what's sometimes called a path-specific notion of causation, or I talk about it in my 2003 book as involving a notion of contributing cause or causation along a route. So you want to make that distinction too. There are a bunch of other distinctions. Now, but that's only part of the story.
Of course.
Because in addition to different causal notions, I claim the following. The basic interventionist notion of causation, I think, is a very kind of weak or minimal notion. All that it really involves is the idea that there's some way of wiggling the candidate cause such that the candidate effect will change. Well, obviously, in many, many contexts, you want to know a lot more than that. You want to know a lot more about the detailed character of the relation between C and E. And I don't in any way claim this is a complete framework or a complete classification, but I have several different categories that I think are important when we try to understand what I call distinctions within causation. So in other words, we have a bunch of relations. They satisfy this minimal interventionist condition for causation I was talking about a moment ago, but they differ in other ways. We can make distinctions among them. So for example, causal relations can differ in how stable they are, or as I use the language, how invariant they are. So it might be that if you wiggle C, E will change, but only in very, very specific background conditions. So the CE relationship is very sensitive. You change anything even a little bit, and the causal relationship between C and E breaks down. Another possibility is that relationship is comparatively stable, or maybe even extremely stable. Pretty much no matter what else you do, as long as C takes a certain value, E will take a certain value. And of course, other things being equal, we value the stable relationships. We try to find them. If you find a stable relationship, then if it holds in one context, you can exploit it or project it to another context.
Well, wait, let me just, as an example, I mean, just to go, give like the tried example of billiard balls, right? So that would be a highly invariant relationship. The billiard balls.
What would be?
Two billiard balls, one billiard ball hitting another, and then the projection thereafter. You could do it in water, you could do it in heat, and the calculations would hold over lots of invariant situations, right? What would be an example of one that is non-invariant that jumps to your mind?
Okay. Think about an experiment which might be done, say, in a social science context. You're interested in whether a certain teaching protocol or academic educational technique or regime works to improve academic performance. And you do, as people in this area do, you do a randomized control experiment. You have you treat some of the students, you expose some of the students to the educational regime, and you have a control group that aren't exposed, and you find in the particular experimental group that you're making use of, maybe it's someplace in the middle of Indiana, this educational regime boosts academic performance. You then take this regime and you try it out in San Francisco or in New York City with different populations, and it doesn't work there. That would be an example of a non-invariant or relatively non-invariant relation. It might be that the relationship is genuinely causal, and your randomized experiment showed that, but it's sensitive in all sorts of unknown ways to, features of the particular environment, the particular population of students you're working with, and so on and so forth. And so it doesn't generalize very well. And I think it's unfortunately true that, at least at present, a lot of the causal relationships that are discovered in the social sciences and to some extent in psychology too, they tend to be relatively non-invariant. They don't export very well.
I mean, it seems like the vast majority of causal situations that we're interested in are going to be of that type. Are the ones that matter to us the most seem to the biggest class that matter to us are non-invariant types. Is that accurate?
Well, I think I think it really depends on the particular case in hand. And I hate to overgeneralize here because I'm going to get people in anyone in any one of a number of various scientific disciplines who may hear this is going to get upset.
Okay.
I think, in fact, that the relationships that are discovered in physics and chemistry and the more, what shall I say, molecular or physiological parts of biology, they tend to be more stable or invariant than the relationships that we discover in say economics or psychology. Now, often, of course, we're interested in the relationships that are discovered in biology, chemistry, of course, but what is really a particular interest to us are these relationships in social science and psychology, because since causation has to do with what will happen under interventions, we want to discover relationships that we can make use of for social policy purposes. But it turns out that those relationships, even if causal, tend to be, they have very circumscribed conditions of application. And exactly how one responds in these sorts of circumstances to that problem, I think, is it's a really interesting and delicate question. You can always say, well, okay, the really stable relationships are there even in the social sciences, and we just haven't found them yet. That's one possibility.
How likely is that?
What?
How likely is that?
I guess at this point, I'm a bit skeptical that anything like that is true. But
well, is it maybe could one generalize and say, because there are different. Maybe you have more to say about this, but the physics, the chemistry, these are all micro scale. I know there's macro physics as well and macro chemistry, but is it accurate as a generalization to say that invariance decreases as scale increases, or as, I suppose, complexity increases?
Yeah, I would think probably complexity is maybe the relevant consideration here, because of course Newtonian gravitational theory and general relativity works very well for all sorts of very large scale structures in our universe. So I don't think it's just a matter of size, but it may very well be partly a matter of complexity. But in a way, when you talk about a system being complex, that's just sort of I'm not sure how helpful that is, just because it seems to me to be kind of a label for everything that we don't understand. So I think the general question of what makes a system complex and what is it that is going on in those systems that is kind of makes them so refractory to at least simple forms of causal understanding. I think that's an extremely deep and interesting question.
Well, I'm going to go ahead and jump in here. I know that I keep interrupting us and interrupting your trains of thought, but I'm going to ask about neuroscience and brains then, but because a lot of the causal cognition work is done, and a lot of the armchair philosophical thought experiments are done on relatively simple systems, right? But then, and that's hard enough to grapple with as you go through in detail through the book with all of these different examples. What is your outlook on how we will be able to scale these concepts? I use the word scale, but in terms of applying this functionalist approach to causation to complex systems, in my case like brains, but also in psychology. And what I really want to ask you as a follow-up is what you see, if you have thoughts on this, as the connection between a brain, a mind, and behavior. How do you see them causally connected? Are you brave enough to tread those waters?
Well, let me start with your first question, which, as I recall, had to do with applying causal thinking to a system that is as complicated as the brain. And it's certainly true that there are features of that system, and indeed other similar systems, that pose particular problems for causal analysis. And let me just mention two. One is the presence of causal cycles of various sorts. In other words, where C influences E, and E influences F, and F influences G, but then G comes back around and influences C. This is certainly, I think, something that you find in going on in neural processing. And then another thing that I think makes the analysis so difficult is that you are involved in somehow trying to understand processing that's going on at different levels, so to speak, at the same time. And issues about whether there can be causal relations across levels, et cetera, then, and if so, how you are even going to conceptualize that, that becomes very, very important in this context. In some of the physical systems that we were talking about earlier, not brain, but simple physical systems, you often have a relatively neat separation between levels. So if you want to understand what's going on at one level, you don't necessarily have to pay attention to what's going on at another so-called lower level. So there's a certain amount of autonomy of levels, so to speak.
Well, that exists in neuroscience versus psychology as well, right? That a lot of people think that autonomy needs to maintain because it's dangerous or maybe reckless to start talking about between levels.
Start talking about what?
About explanation between levels, that everyone needs to stay on their plane.
But I think that in the case of the brain, that sort of strategy isn't going to work. There isn't the clean a separation of levels. And I think the prospects for a completely autonomous psychology that is, autonomous with respect to what's going on in the brain, I doubt that that's going to pan out very well. So I think you have this situation when you have, so to speak, leakage between levels in structures like the brain, and that makes also the causal analysis, very very difficult. And of course, the other thing is we don't really, at this point, have all that good a handle or understanding on exactly what the units, so to speak, are that we would expect in the case of the brain to be standing in causal relations. One would like, obviously, given how many neurons there are, that the level of analysis had better be something larger than the individual neuron.
Yeah.
But what is it? Circuits, populations of neurons, something else. If you just talk about, gross anatomical areas like V1 or V2 or the hippocampus or something like that, that seems, far too coarse-grained for these to be useful units of causal analysis. Yeah, so I don't have detailed or useful suggestions about how to proceed. There's increasing interest, I know, because I see papers about this from time to time among neuroscientists about what, if we want to have some sort of causal understanding of what's going on, first of all, how do we even think about what causation should mean in this context? And then, as I was saying a moment ago, what are the units? What's the level at which we can plausibly hope to find interesting causal generalizations?
Before we get off this topic, so I don't know if you want to talk about downward causation at all. And I was hoping to kind of tease you out to talk about that when I asked you my second follow-up question, which is what you see as the causal relation between a brain, a mind, however you define mind, and overt behavior that we can measure.
Yeah. Well, so as you may know, this isn't in my most recent book, the Causation with the Human Face book, but in other recent papers, I've defended the idea that there is such a thing as downward causation, understood as, causation from a so-called higher level, which usually the higher level is just a kind of coarse graining of some lower level. There can be causation from a so-called higher level to a lower level. I've been influenced by a couple of recent discussions and books of this about this. There's a long and quite interesting book by George Ellis, the physicist and cosmologist, among other things, where he, I think, advances he provides a number of plausible physical examples of downward causation, that is, examples from physics. Dennis Noble, in biology, who works on heart modeling, among other things, provides plausible examples from biological context. So yes, I see that. I do think there's such a thing as downward causation, and I claim anyway that it fits naturally within the interventionist framework, because all that has to happen is you wiggle some relatively upper level or coarse grained variable, and something at a so-called lower level changes in response. That's enough for causation. It's not, you don't really require anything more than that. Now, there are lots of people who think that there are, metaphysical and other kinds of objections to downward causation, but partly because the interventionist framework for causation is so metaphysically thin, so to speak.
Yeah.
Don't have any problem, I don't think, with making sense of downward causation.
So does brain cause mind and mind cause behavior? Does brain cause behavior and mind?
Yeah, I'm happy with causal relations running in
All directions? Does mind cause?
all of these directions. Now, of course, when I talk about the mind, I assume that this is just something physical. It's just a kind of more coarse-grained and abstract way of describing physical going on. So I'm not here, embracing any kind of dualism or anything like that. I don't think the mind is something that's separate from the brain. It's just roughly when we describe psychological or mental goings on, we're just talking about what's going on in the brain, or maybe even in the whole person, just at a certain level of relatively coarse-grained description.
Doesn't extend to the environment. You're not a pro-inactive approach.
That's something that I haven't thought about a whole lot. I'm not. I mean, I get why people want to talk about the role of the environment and embodied cognition and all that other kind of stuff. I'm not sure at this point that any very interesting science has come out of that.
Okay. I'm going to have Michael Anderson on soon, so I'll pass that on to him and see what he has to say about that, because he's a pro-inactive. Can we talk about laws for a second? So I'll let you off the hook with the brain, behavior, mind stuff here, and go back to kind of the invariance aspects of causation. I realized, again, growing up in science, as I was growing up in science, especially physics, of course, where everything is laws, the gravitational law, etc. I sort of just accepted that there are laws in the universe. And then recently I was in conversation with someone and I realized I had changed my mind so much on this that I told this person that I don't believe in laws. And then, of course, they made a lot of fun of me. And do you think that the earth is just going to fly away from the sun? That sort of stuff. Do you believe in laws, or how should we think of laws?
Well, yes, I do believe that there are laws, although I may have a somewhat different picture of what a law is than perhaps other philosophers do. So I just think of laws as highly invariant generalizations.
But that means a law doesn't exist, right? That means that you give the name law to this thing that doesn't vary much, but it's not like a fundamental part of the universe, or is it?
Well, so here's the way I would think about it. I think there's so causal claims and even things we might want to describe as laws can vary in their degree of invariance. Okay, so something can be invariant only under a very limited set of changes in other kinds of conditions, or it can be invariant under a hugely wide range of changes in other conditions. So take something like so-called Hooke's law, the so-called law, which says that the force exerted by a spring is inversely proportional to the it's the negative of the extension. It isn't inversely proportional. Sorry, it's the negative of the extension of the spring. And that's a generalization. That's a kind of simple F equals minus kx. That's a kind of simple linear relationship. It will describe the behavior of some springs in a certain range. But of course, if you stretch a spring too much, it'll break. And the law will no longer describe at all what the restoring force will be. So that's a generalization. It expresses a causal relationship between the extension and the restoring force, but it holds only in a relatively limited range of circumstances. Compare that with the Newtonian law of gravitation. Holds under a very, very wide range of different circumstances. Holds near the surface of the Earth, holds for our solar system, holds elsewhere in the universe, holds for masses of varying sizes, et cetera, But the Newtonian gravitational law itself will break down under some circumstances when, for example, very massive objects are with strong gravitational fields are in play when we're dealing with velocities that are very large in comparison with the velocity of light. Then Newtonian gravitational theory no longer applies very well, and we have to go to general relativity. So that's my picture. We have the generalizations of more or less invariance. So far, I think it's a plausible claim, although some will dispute this, that we haven't discovered any generalizations that are absolutely exceptionless. It would appear that in every case, there are circumstances under which the generalization will break down. And this is true even for the highly invariant generalizations that we give the name laws of nature to. So in the case of general relativity, for example, it's thought that it will break down at extremely small length scales, the so-called Planck length. And that's part of what the search for a theory of quantum gravity is all about. So kind of degrees of invariance. It's not like there's something magical about the notion of law. It's sort of like what's going on with the spring and the restoring force, except much broader range of invariance. And I think that's all there is to it. I don't think that anything more elaborate than that needs to be said about what makes a generalization count as a law of nature.
All right. So in the book, you spend, I think, 3 chapters talking about invariance and different causal cognition empirical studies related to invariance. And then you finish the book with a chapter on proportionality. What is proportionality, and what, maybe your favorite illustration of results related to proportionality?
So I said earlier that even if you, among those relationships that count as causal in some minimal sense, as captured by interventionism, we can make further distinctions. One distinction we can make has to do, as I've been saying a little while ago, with how stable or invariant the relationship is. Another distinction has to do with to what extent the relation between the cause and the effect are proportional. So that's another distinction within causation. Now, what does proportionality mean? Well, the rough idea is that the cause and the effect have to fit together in an appropriate way. I'll give you an illustration in a minute, but I also, before saying any more, I wanted to flag that this is also by no means an idea that's original with me. It was introduced into the philosophical literature by Steve Yablo, maybe now probably coming up on maybe close to 30 or 25 years ago. So here is one of Yablo's illustrations of the basic idea. Suppose you have a pigeon, and the pigeon has been trained in such a way that it will peck at red and only red targets.
Okay.
You present the pigeon with a target that's a particular shade of scarlet, and sure enough, the pigeon pecks. Now, compare the following 2 causal claims. The scarlet color of the target caused the pigeon to peck. That's causal claim 1. Causal claim 2, the red color of the target caused the pigeon to peck, because after all, the target, in virtue of being scarlet, is red. And the intuition you're supposed to have is that the second causal claim, the red color of the target caused the pigeon to peck. It somehow seems better or more satisfactory. And the reason why it's more satisfactory is that we said in the very setup of the problem that the pigeon would peck whenever the target was red. So intuitively, if you if you say that it's the scarlet color of the target that caused the pecking, you've described the cause in too narrow a way.
Okay.
it's kind of overly
because it doesn't account for all the other shades of red that would also cause
right.
yeah.
That's right. So it's an interesting question. So this is this kind of intuitive idea that the cause and the effect should be at the same grain, so to speak. That's another way of thinking about it.
Okay.
So the kind of graining that goes on when you talk about the cause of scarlet is it seems too narrow. It seems overly specific, so something like that. Given that the effect is pecking, you want the cause and the effect to be at the same grain. But several issues then arise. First of all, can you make this precise in any way? I've been talking about it in a sort of metaphorical way. And then secondly, to what extent do ordinary people in their causal judgments respect the idea that they prefer causes that are proportional to their effects? And that's one of the things I try to do in the chapter. I won't bore you with the effort to make things more precise, but there is some experimental work that does seem to show that people do tend to prefer descriptions of causes that are proportional to effects.
Is this related to intuitions? But you spend some time in the book defending intuitions. Maybe you could say a word about that. I meant to ask you about it earlier, but we can tack it on here.
Sure. So it's a very common practice within philosophy generally, not just philosophical discussions of causation, to appeal to so-called intuitions. So you have intuitions here are just sort of kind of the one way of thinking about them is they're fairly spontaneous judgments about particular cases. And reasoning about philosophical matters in this way is a very, very old tradition in philosophy. If you go look at the Platonic dialogues, they're full of these sorts of arguments about, would you consider this a case of justice? Would you consider that a case of justice? Is this a case of knowledge? So on and so forth. And unsurprisingly, the philosophical literature on causation is also full of examples that involve appeals to intuition. That is what we would kind of the man in the street would ordinarily, or person in the street, excuse me.
Oh, thank you. Yeah. Oh, you saved yourself. Nice job.
The person in the street would kind of spontaneously say, and then philosophers try to construct theories of causation around this. So,
and this got a bad name after a while, right? Because it's not experimentally robust. It seems, and especially given, and I know that you find us all to be extremely rational and correct humans, but we do have human error, and those, there are errors regarding our intuitions as well. But
yeah, so there has been a huge amount of discussion recently about the role of these appeals to intuition in philosophy. Some philosophers have criticized any kind of appeal to intuition. Others have worried that when philosophers appeal to intuitions, they're basically, among other things, making claims about how people or so-called ordinary folk would judge, or what they would say about various situations. Maybe those claims that the philosopher makes from the armchair are not empirically very well supported. That's been another line of critique. One of the reasons why philosophers, or at least some of them, have been unhappy with appeals to intuition, is that at least some philosophers who appeal to intuition have assigned intuition features that is very hard to see within any kind of naturalistic or scientific framework, how intuition can have those features. So, people have thought that when you have an intuition of something, that's involves some kind of rationalistic grasp of the underlying metaphysical nature of things, something like that. I do defend appeals to intuition in connection with reasoning or thinking about causation to some limited extent. That is what I think is going on when a philosopher describes a case and then says, my intuition about this case is such and such, is simply that the philosopher is reporting what he or she thinks or judges about the case and what the philosopher expects that other people will judge about the case. So if I give you this is a standard scenario that's very, very simple, and I think uncontroversial. If I describe a case in which two people, Billy and Susie, are throwing rocks in a bottle, and both rocks are headed right toward the bottle, but Susie's rock gets there a little bit before Billy's, and the bottle shatters. And then if we ask, who broke the bottle or which rock caused the bottle to break, well, then, of course, it's the one that got there first. That's our so-called intuition about the example. And again, I don't think there's anything very controversial about that, just understood as a claim about, how people would judge or think about the example. Now, one of the things I claim in the book is that, at least to some extent, people in psychology who are doing experiments about the kinds of causal judgments that people make, they're basically in the same business as the philosopher who describes intuitive reactions to judgments. The psychologist is maybe being a little bit more systematic and maybe looking at a broader range of subjects. It isn't just the philosopher and a couple of the philosopher's friends who are the source of the information about how people judge. But I think it's basically the same sort of undertaking. And to the extent that that's so, in other words, to the extent that the philosopher is just making empirical claims about he or she or most other people will judge, you might wonder whether it's an empirical matter the claims are correct or not. And of course, you can go assess that in kind of obvious ways. But there's nothing problematic about that kind of appeal, that kind of use of appeals to intuitions. You don't have to get into some elaborate rationalistic story about insight into the nature of things or anything like that to defend that kind of use of intuition. Now, an important distinction, though, that I do make in the book is the following. I think it's one thing to say that philosophers may have a pretty good sense about how other people would judge in a certain range of familiar cases about causal relationships. I think that philosophers, and indeed people in general, though, have very little insight into why they judge as they do. In other words, I might be able to tell you that in a certain situation, people are going to judge that X caused Y and Z didn't cause Y. But if you ask me then, well, how did you come up with that judgment? Or what was the underlying causal processes that led you to make that judgment? I don't think that that is something that, at least in most cases, we're in a position to we can't really answer questions about matters of that sort via appeal to intuitions. In other words, we just don't have the access via introspection to the causal processes that generate our intuitions. And I think one of the things that one of several things that can become problematic about appeals to intuitions in philosophy is that people sometimes think not just that they have access to the judgments that they and other people are likely to make, but that they have some access to the underlying processes that are generating those judgments, or the underlying distinctions that they're relying on when they make the judgments, and so on and so forth. And I think that's a good deal more problematic. To get at the underlying processes, you really need something like experimentation, I think. of the sort that psychologists do, or at least some much more sophisticated form of causal analysis. You can't really accomplish it just by introspection.
Well, right, because in my view, we confabulate the reasons why, the causal explanation of why we do almost anything, and it's embarrassing.
Yeah.
But we do.
Yeah, there's a huge amount of psychological evidence that people, at least often, confabulate about why they have made the judgments and decisions made. And I'm certainly not someone who's going to deny that that's the case.
All right, Jim. I have one more question for you before we go into sort of some extra time that I will release only to the Patreon subscribers, people who support the podcast. Before I ask you this one last question, is there anything that we have missed that you want to highlight about causation with a human face that we haven't gone over? I know we kind of skipped around a lot of stuff and I interrupted and we went back and forth, but did I miss anything or did we?
Well, just very quickly, a couple of things.
Great.
One of the things I would like to emphasize is what I see as the very fruitful interplay between the normative and descriptive in thinking about causation and causal cognition. I would emphasize to philosophers that the causal cognition literature that's been produced by psychologists and cognitive scientists is really a very, very rich source of information and examples for many, many of the problems that they're interested in, and they should really pay attention to this. Going the other way, as we were suggesting earlier, I think that paying attention to the ways in which people actually make causal judgments can often be rather suggestive for the right kind of normative thinking about causation. If I may use an analogy, there's in trying to develop structures that do computer vision effectively, it's turned out to be very, very useful to try to investigate how the human visual system does it.
Yeah.
And I think a similar thing is going to be true in connection with causal cognition. If you want to build a machine that's good at causal inference, you should pay some attention to how it appears anyway human beings do it. Now, that isn't to say that the machine is going to be successful by copying in every respect what human beings do. The machine has certain kinds of abilities, like, abilities that multiply enormous numbers together very quickly and so on, that human beings don't have. But I want to say that the descriptive stuff can be very, very useful from the point of view of people who are interested in normative theory. So I want to just kind of get across this idea that there's this possibility of really, really fruitful interactions between the two.
Hold on. Before you go on, I have just a follow-up question about that, because you alluded to the visual system and building these networks that map onto our visual system in our brains and can explain brain activity. In that case, and we've talked about that kind of approach a lot on the podcast. In that case, the network maps onto a well-known one of the visual streams in the brain, well-known architecture and hierarchical structures, right? The hierarchy of processing. And I don't even know what the current neuroscience of causality is, like what, to use a phrenology approach, where in the brain causality happens, how causal reasoning happens in the brain. Do you have any idea? I really don't have any idea what the current science is, because you're talking about these, if you created a neural network that was great at causal inference, maybe we would learn something about how humans do it, but it's not clear to me. There's not a ready known system in the brain that we could try to map that onto, at least that I'm naively.
No, I think that's true. I think very little is known about the the underlying neurobiology
Okay.
of causal inference. I will say the following, though. In the normative work that's been done on causal inference, one of the things that people have, one of the conclusions that people have come to, and at least this is my interpretation of things, is that you basically need something like two levels of representation. You need a level of representation that sort of tracks correlations. But of course, we know causation isn't correlation, just correlation. And then, so the way in which this is, captured in normative theorizing is there's an additional structure over and above the correlational structure that, for example, might be represented by something like a directed graph or a set of structural equations or something like that. Now, there's also a substantial amount of evidence that I go through in the book that human beings in their causal representations, wherever these may be located in the brain, also have this kind of two-level kind of representation. There's a sort of more associationist or correlational level of representation, but there seems to be something on top of that is apparently essential to successful causal cognition. And this isn't just a matter of the representation of correlations. And I myself think, and this is a claim that Pearl and others have made, that this has implications for designing a machine that will engage in successful causal inference or learning. It's not going to be a machine that just represents patterns of association. It's going to have additional structure to it.
Do you and Judea Pearl hang out? Do you guys do coffees and make causality jokes and stuff?
No, not really. I mean, I do know him.
Yeah. Okay.
And certainly have talked to him on a number of occasions, but no, we don't hang out together, particularly since right now he's in Los Angeles and I'm in Pittsburgh.
And you're retired. You told me between these takes that you were retired. I didn't know that. Congratulations on the retirement, and I hope that.
Well, thank you.
Yeah.
Thank you.
Yeah. What else were we missing? You said you had a couple things. Did you cover them all?
Here's the other thing, and I guess it's implicit in what I've said already. One of the things that really appeals to me about causation and causal reasoning, just as a general topic, is that it spans so many different disciplines.
Oh.
So it's work in philosophy that I think is at least sometimes fruitful and interesting. But then there's also work in machine learning and statistics, econometrics, and in psychology, and all of these, people in these different disciplines talk to one another, at least to some extent. And so there's very, very fruitful interactions. So if you're a philosopher and you're interested in cross-disciplinary work, this is I think a very interesting place to be. And it is an area in which, at least as I see it, identifiable progress is being made. We're learning more and more about all sorts of different things, and the issues about causal analysis of complex systems, thinking causally in a fruitful way when you have so-called big data, enormous amounts of data, building machines that might conceivably engage in successful causal inference. These are really, I think, exciting and interesting issues. And so I just want to say, if you're a philosopher or even someone in another discipline, this whole complex of questions and issues is a really it's kind of fruitful and interesting place to be from my point of view.
If we built machines that did great causal inference, thinking about wanting to build machines that mimic our own general kinds of intelligence, would that mean that they would confabulate the reasons why also?
Well, that's a very interesting question. That's a very interesting question. So, I guess to some extent, our tendency to confabulate is, you might think of it as a sort of byproduct of an impulse that we have that is actually quite useful.
Yeah.
Is searching for explanations for things.
Yeah.
And I mean, we are the kinds of creatures that when something happens, we want to know why. We seem to have an impulse to try to answer that question. And of course, that sometimes leads us to come up with answers to such questions that, have no empirical support. But
right. It's like we throw the dice and just are satisfied with wherever they land, and at least in this respect.
Maybe I think the relevant question we should be asking ourselves is not whether it's true. Does this impulse sometimes lead us to make mistakes or lead us astray? But would it be a good thing if we didn't have the impulse at all? Because that maybe is the trade-off.
Yeah.
And it's not at all. It seems to me the answer to that last question is probably clearly no. So it's an impulse we have, but it gets it can go into overdrive in ways that's not so. Not so cool.
There's no way it's an evolutionary mistake, because evolution does not make mistakes. But that's a whole nother 2-hour discussion in there. Okay, so I'm going to close before I ask you just a few kind of one-off questions. If you had so you mentioned progress and that we're making discernible progress in causation in lots of different fields. If you had a magic wand that could give you the one thing you think that would help you make progress as a philosopher in causation, be they experimental empirical results or some philosophical kind of breakthrough or realization, do you have a sense of what you would wish for with your magical wand?
That's a very good question, and I don't have a single answer to that question. I think a lot of the progress that will occur is going to have to be somewhat incremental. There will be, mathematical advances. There will be additional experimental work that explains better what it is we're able to do. I guess one general thing that I would be very interested in understanding better is the following. We as humans, at least as adult humans, seem to have abilities at causal cognition that are in many ways pretty superior to those of other animals, including other primates. But I think the exact character of our advantage is not very well understood. That is, and I don't mean to suggest it needs to be just one thing either, but what exactly is it that makes us so much better at causal inference than other animals? I mean, other animals are great at, kind of more associationist forms of learning. So that by itself doesn't seem to be what the difference is. And so I think that's a really that's a really interesting empirical question that I'd like to know the answer to.
Yeah, me too. I meant to actually ask you about that difference. Of course, it's not going to be one thing. As we've discovered with causality, it's complicated. It's always complicated. All right, Jim, thank you so much for the book. Are we going to see another one in 10 years?
Sorry, will I produce another one?
In the next 10 years?
I don't know. I mean, I have some ideas that might possibly go into a book. Although I'm retired, I'm hoping that I'll continue working as long as that's possible. That's certainly my plan. So we'll see.
You don't seem retired. I appreciate your time here with me today, and thanks again for recording it again. I had even more fun this time, actually speaking with you, which was somewhat surprising, given that we did it before. So thank you.
Oh, you're very welcome.
I alone produce Brain Inspired. If you value this podcast, consider supporting it through Patreon to access full versions of all the episodes and to join our Discord community. Or if you want to learn more about the intersection of neuroscience and AI, consider signing up for my online course, Neuro AI, The Quest to Explain Intelligence. Go to braininspired.co to learn more. To get in touch with me, email paul@braininspired.co. You're hearing music by The New Year. Find them at thenewyear.net. Thank you for your support. See you next time.